My name is Diego, and today I will be talking about the project that my team, Robotic Eats, has been working on, which is called Automatic Injera Maker. The team is formed by 4 different electrical engineering students from 4 different states. We have Marina, Joseph, Jordan, and myself. And together we have been trying to automatize the process of baking injeras. Injera is a spongy flatbread from Ethiopia, which is eaten in virtually every meal by Ethiopian families. You're probably wondering, why are 4 American students concerned about Ethiopian bread? And the reason why is because here in the US, we actually have a very large Ethiopian presence. We have the second largest minority group among African Americans, and we also have a presence who has been constantly expanding. In fact, from 1980 to 2012, the total Ethiopian population has increased by a factor of 2,453%. So it's definitely a market that it's expanding, that they were trying to tap in. We began by conducting a survey, and we asked restaurants to tell us what is the main challenge in making injera. And 40% said that fermentation is an issue because fermenting the batter here in the US does not come out to be the same as fermenting it in Ethiopia. And that affects both the taste of the bread and also the consistency. So, however, about 60% of the restaurants has told us that they actually have issues with the fact that baking injeras is such a labor-intense and time-consuming process. And after some market research, our team has estimated that if a restaurant were to substitute a cook with an automatic injera machine, they could possibly save up to $180 per week. For that reason, our team has decided to focus on the baking of injeras rather than the fermentation. Now I'm going to pass it on to Joseph, and he's going to sum up a little bit what's the progress already been done by our team. So thank you very much.
My name is Joseph DeMassimo, and I'm here to tell you what Robotic Eats has accomplished during the first semester. We started with our NAT chart, got that organized, moved into our initial research for what has already been done in the field, moved into marketing research, and then ultimately onto the design. On our NAT chart, we use an app called ClickUp. It lets us put everything we need in one place so we can keep up in a timely manner. On there, we have our requirements gathering, our initial research, our developing our contract with our mentor, the brainstorming, the market research, developing a multi-site strategy, our progress report, our video, and of course this presentation. Our initial research led us to industrial size injera makers. They don't quite fit the mold for the mom and pop Ethiopian restaurants that will be our target market. They're bulky, they don't fit in a kitchen. The price range is really high. I've seen some of them sell for $15,000. They overproduce injera. A normal restaurant would end up wasting thousands of injera per day, and the shipping cost to get it from Taiwan is extremely high as well. So there we moved into our market research. Initially, we sent out emails to about 60 Ethiopian restaurants across America. We didn't quite get the feedback we wanted or the participation, so we moved to a more personable approach using Facebook Messenger as well as the mentors contacts in the Ethiopian community. We asked open-ended questions to ensure we can get good feedback. That helped us to analyze the cost per employee and for the business themselves. But what we really want to know was what our target market needed from our product. And that survey allowed us to get that. And with that, we can move into the design phase to make making injera easier and more effective. Our first design was by Diego, and it runs on a 2-dimensional track, much like how 3D printers work nowadays. It put the batter on, and it can move in a circular motion to get the injera batter flat and evenly distributed. Our second design was by Marina, and that entailed with moving the hot plate in a circular motion for that nice dispersion of the batter. Our third design by Jordan is a slight change to the second design, but instead of moving the hot plate, we will take a shaft that will disperse the liquid batter and move that around the hot plate in a circle. We're not 100% set on a concept yet. We're still moving through that phase, but this will allow us to really give our customers what they need to make the Injera process much smoother and easier and more cost effective.
Hello, my name is Marina and I'll be talking about data analysis. According to the U.S. Census Bureau, population from Ethiopian ancestry in the U.S. has increased. These numbers only reinforce the fact that Ethiopian pop culture continues to expand throughout the U.S. over the years. Robotic Eats was challenged to learn about the Ethiopian food, but more importantly, learn about the most important element of an Ethiopian meal, injera. For data analysis in our senior design project, Robotic Eats was able to gather an estimate number of restaurants throughout the US that serve Ethiopian meals, and thanks to Google Maps, we're able to estimate a minimum of 1,240 restaurants. A small percentage of those restaurants were approached via email, Facebook Messenger, telephone, and in person in order to gather responses to a survey or team formulated to understand Injera's market. And based on that, the following data was gathered. As seen in the pie chart, we can see from our interviewees, 76.9% make their own injera, while the remainder, 23.1%, buy it from other manufacturers. The survey questioned restaurants about their total amount of injera sold per week and an approximate cost per week. In average, each restaurant sells about 1,201 injera pieces, and the average cost was around $0.46 US. Robotic Eats evaluated a way of cutting their cost. Out of a 25-pound Teff flour bag, the restaurant can make up to 277 pieces, equating to a prime cost of $0.27 US. If the restaurant only used an employee paid with the minimum federal wage, which is $7.25 US, to make an injera, and each injera took about 2.5 minutes to make using the automatic injera maker, which will pour the batter, bake it, and remove the injera, the labor cost will be around $0.30 US. That will total actual minimum cost of $0.57 US. If the restaurant produced 1,004 injera pieces per week, the total cost will approximate to $686.28 US, a price that is significantly less than what the restaurants provided. It's about 26.3% lower to be exact. For restaurants buying their injera, the potential savings will be even greater. For the service, it was estimated that in average, the restaurants pay around $1.46 per injera bread. If the restaurants buying injera decide to make their own using the automatic injera maker, they could potentially save up to 39% of their total cost. On the other hand, the survey also focused on gathering restaurants' perspective in the injera making process. We asked, what did they consider the most difficult part of making injera? While some of the restaurants seemed comfortable with the process, most complained about the fermentation process and the time consumed baking and removing the injera from the griddle. We also asked if they will make their own injera if an injera maker was in the market. Responses varied as seen in the pie chart. 39% responded yes, 15% responded no, and 46% responded maybe. Having such a high percentage where restaurants will be open to the idea of using an injera maker opens millions of possibilities for Robotic Eats to design an automatic injera maker that will suit the customer's primary concerns and needs.
Hello, my name is Jordan Clark, and I'm also a member of the Robotic Eats team working on the AIM project. I'll be discussing the project plan for the second semester of the senior design course. The second semester will build on the work currently be completed in the first semester of the course. This will include market research and the preliminary design concepts, and it will further develop those to produce a final design and prepare final documentation, as well as build and test a prototype to be demoed at the end of the semester. Other tasks similar to the first semester will include keeping up with a notebook and a final quiz, as well as the final or the progress and final report and presentations. Here is a high-level view of the estimated schedule for the second semester, starting on January 15th and ending in the end of April with the final prototype demonstration. And here are some other dates of the auxiliary tasks or the separate tasks outside of the design development, including the first and last video, the progress report and presentations, and of course the final quiz and demo. Here's the same schedule, just shown in a Gantt chart for a better visual representation that shows the logical flow of the different tasks. So some information on the resources and logistics for the second semester. The design is planned to be split into subsystems and allocated amongst the team members so that the work can be completed in parallel. Most of the work, given that it's an online course, plans to be done remote through communication via web-based and telecommuting and phone conferencing, and utilizing home office and laboratory setups in order to finish the design and build a prototype. The caveat to this is that the shipping may be required of the prototype so that we can make sure the different subsystems are interfaced correctly and we can test the final product. Most of the resources, as mentioned previously, will be home office setups using basic software and open source software packages. But there will be resources that will be available through Arizona State University, including various software packages to use in the design, as well as funding for the prototype components. So a little info on the final design and prototype build. Obviously, it'll require an application of engineering knowledge that the Robotic Eats team members have gained amongst along their academic careers. The brain for the product is planned to utilize the Arduino microcontroller board. This is commonly used in industry as well as academic settings. And the design will also include, in addition to the controller, various motors, sensors, and of course mechanical hardware. So in conclusion, injera is a bread commonly used in Ethiopian cuisine, but certain aspects of the baking process can be difficult to do efficiently and with consistency. The Robotic Eats team has done market research to show there's an increasing number of Ethiopian-based restaurants and Ethiopian culture located here in the U.S. So there's definitely a market for an injera product, and through surveys we've discovered that the baking and pouring process could be automated and it seeks to be automated in the injera or in the Ethiopian market. So the goal of the Robotic Eats team and the AIM project is to provide an affordable option to automate this process that can be used in home and commercial applications. Thank you.